All right, gang. So, like I said, we'll be doing our first kind of official lesson today. So it says 1.3 notes. So that's chapter 1, section 3. And so we'll go through this chapter pretty quickly. I think there are about 3 really sections we really cover. We cover 1, 3, which is algebraic expressions, and then we get into a little bit of equations and inequalities. So really a lot of review kind of stuff, and and uh, and then so we'll probably end this chapter with a quiz sometime next week. Okay, so it's not like a full chapter where we're gonna end with a big test at the end. We'll start those in chapter 2. So with that said, let's go ahead and get started. All right, so example 1 is about evaluating an algebraic expression. So that basically means what is the value of the expression. All right, so in number 1, our expression is 7 times the quantity a plus 4 plus 3b minus 8. And then they define the value for us that a is -4 and b is +5. So if we're going to evaluate, we're basically just going to, substitute in for a and b, and then simplify. Okay, so we have 7 times the quantity, and then we're going to go ahead and sub -4 in there, plus 4 plus 3, and then sub 5 for b, and then minus 8. Now, if you have your calculator at this point, I like on this order of operations stuff, I like to try to type it all in on one line, and then I like to be able to work it as well, just to make sure that that's kind of good calculator practice if you have one. I'm going to kind of work it out more by hand, but if you have your calculator, go ahead and punch it in, and we'll see if we agree at the end. Okay. All right. So it looks like we should come up with 7. Anybody have any questions on that one? That's a pretty simple example. Everybody good there? All right. So the next one is a little bit tougher because we have a fraction, we have an exponent. So I'm going to give you guys just a minute to get ahead of me on that one. I'll go ahead and just kind of write it up where I'm plugging it on the board. Feel free to work with people around you. I probably won't call on you or anything for this one, but just give you a minute to kind of just get ahead of me here. All right. Anybody want to volunteer what they got? Any brave souls out there? Nobody? Yeah. Sorry. 3/4 is actually correct. So good job. All right. So 3/4. How do we get it? Obviously, that expression on the left is just equivalent to 1/2. So we have 1/2 plus whatever 1/2 squared is, right? So if I'm punching that into a calculator and it's a fraction, I need to either punch that in as 0.5 squared, or 1/2 needs to be in parentheses. But anyways, that is 1/4. It's equal to 1 squared over 2 squared, right? So 1/4 or 0.25. And then this is where I wish I had my calculator that worked on the screen, but I don't. There is a function on your on your TI-84 that I'll need to show you, because like if you punch that in 1/2 plus 1/2 squared, it's going to give you a decimal, and if you like need a fraction for like Math Excel, well, hopefully you know 0.75 is equal to 3/4, but there is a function that changes a decimal into a fraction. If you want to try to find that, if you have a decimal, it's under Math, and it's the top option. Okay, but I don't have my calculator working yet. Okay, where I can show you guys on the screen. All right, so we're going to continue to move on with some vocabulary here, some fill in the blank. It says an expression that is a number, a variable, or the product of a number and one or more variables is that would be a term. Okay. So essentially, a term is anything that's all together, right? You go to another term when it's separated by either a plus or a minus sign, right? That's when you go to another term. So a blank is the numerical factor of a term. So that would be what's the number out front of a term called? Say if we have like 2x, what's 2 called? Anybody remember? C word? Coefficient. And then a blank is a term with no variables. Anybody remember what that's called? So like 4 is called a what? Another C word. If there's no variable, anybody remember? Constant. That's what I was looking for. Very good. Thank you for whoever said that. All right, so just some kind of vocabulary there. So number 3, kind of based off this, just defining some things. What is the second term of the expression? So just in the order it's listed, the second term is going to be that guy right there. So 7W. What is the coefficient of the first term? Here's our first term. So our coefficient is going to be -4. And then what kind of term is the last term? So one of the words we just used, I'll give you a second to write it down. One of the words we just filled in the blank. So what's the last term called? Anybody got it for me? Constant, right? So we're talking about -6. Since there's no variable part, we call that a constant. All right, so kind of moving on to the backside of the first page there. Let's go ahead and define these. So like terms are terms that have the same variables and the same power on those variables. All right, so let's just say terms with same variable and I will just put that in parentheses, and exponent. In other words, 2x and 2x squared aren't like terms, right? Because one has a 1 variable, the other one has a 2 variable, right? So what's it mean to simplify anything really? So we would just say to reduce an expression to its smallest number of terms. Reduce expression to its smallest number of terms. And honestly, guys, when it comes to simplifying, sometimes that can get a little subjective, all right? So like you might think an algebraic expression is more simple to use in another form, but really it's important for as far as algebra goes to be able to understand which algebraic expressions are equivalent to each other. All right, so we'll kind of get into more of that later in these notes. Okay, so let's go ahead and do this first one together. Write an expression to represent the following words: 2 times the sum of A and B. All right, so 2 times the sum of A and B. So that would just be obviously 2 times, just 2 as kind of a coefficient, and then the sum of A and B, that's just A and B added together, sum of A and B. So can anybody tell me why that is wrong? Why is that wrong? Yes. Right, so that's just 2 times A. That's just basically, the sum of 2 times A and B, right? So we want the sum of A and B, right? So we need to group them together with parentheses, right? So don't really need that dot there if we have the parentheses. So that's simplified technically. What is another way I could write that? What's an equivalent way I could write that? We're not going to write it down, but how else could we write what's on the board there? What's another way that would be equivalent to that? Any thoughts? What if I distributed the 2? What would I end up with? 2A plus 2B, right? So that's what I'm talking about, just knowing when things are equivalent. Okay, so what mathematical property would you use to simplify that expression? So what we just described there is called the what again? Distributive property. And that's where I say, like, what is more simplified? Is 2 times the quantity A plus B? Is that more simplified, or is 2A plus 2B more simplified? Well, you both have the same number of terms. I think that's just more of a preference thing. Okay. So, anyways, now getting into this like terms idea, right? So it says to simplify the following expressions. We notice we don't know any values for x, y, or z. So all we can really do here is combine like terms. All right. So I like to just kind of, start from left to right here. So I have 3x squared. Are there any other x squared terms? Yes. Right. So those two are going to be added together. When I add those together, what am I really adding? What parts of them am I adding? When I combine like terms, I add the what part of the expression? The coefficient part, right? So we just get 8x squared there. Then we have a y cubed z term, right? Are there any other y cubed z terms? Yes, right? So I'm thinking 9 minus 4 there to get 5. If I have a z variable, I don't normally make my z's like that in real life, but those look a lot like a 2, so I like the little whatever mark you would call that. And then we just have plus 2yz. All right, so why don't you try the next one? And I will call on somebody here, so feel free to compare with a neighbor. I'll give you about 20 seconds, just so you can catch a silly mistake, maybe. All right, how about Drew Werner? What do we get? 3x squared plus 5y squared. The judges agree. Anybody have any questions? Everybody's good on that? All right. So when it comes to like, standard form and stuff like that, we're not really talking about that yet. But if you remember, standard form is like where you go, 2x squared plus 3x plus 4, something like that. If you have multiple variables, that gets a little bit trickier. So even though we're not talking about that, right? Just know that this expression could have also been written 5y squared plus 3x squared, right? And that would be the same thing. Okay. All right. So why don't you go ahead and just try 6? I probably won't call on you for 6, but just see what you get. Okay. So we have negative, or the opposite of the quantity, 3k plus m plus 2 times the quantity k minus 4m. Just try it. Feel free to compare answers. Some people get a little bit confused on that first part. What do I do with that minus sign or that negative sign? And while you're talking it out, I'm going to go ahead and work it out on the board so you can check it when you're ready. All right, so negative k minus 9m or negative 9m minus k. One last point I would make, or any questions before I was going to say? There? Everybody good? Okay, so this is something that may happen even in this lesson, but definitely later in the year, where like if you have an expression that sometimes they follow the rule where they don't want the lead term to be negative. So in that case, just know, and I think that property is kind of listed here somewhere. One of these. Well, whatever property I'm looking for, you may have to be able to rewrite this at times as where you basically use the distributive property to rewrite this as negative k plus 9m. Okay, so that's something that you'll have to do at times. All right. So like that's one where if you entered it as negative k minus 9m on MathXL, it said your answer is equivalent to the right answer, but it's not in the right form or something, that's what they would be looking for. Okay. So that's all I have. So what we'll do at this point is take like probably a 3-minute break. Then I'll post your assignment, and then we'll really make sure everybody's in MathXL, because you'll ask me for help if you can't see it. So